Hey, Mr. Ellinger's geometry classes. We had a little problem with the video, so after school today on Monday, I'm recording a video so that you can watch this thing. So here we go. I can't talk as fast as Miss Young, but I'll do my best. All right. So we're going to talk about some basic terms that we're going to be using throughout this course, and so this is the kind of the starting point. And so we're going to be describing or defining or drawing something about them. We're going to be kind of talking about what these things are, and then if there's a way that we specifically write them, we're going to give you the notation. How do we describe these things? You'll see. Just hang tight. So undefined terms is our starting point. If you think about it, like if you look in a dictionary and you look up a word, then that's defined by other words, and then those words are defined by other words, and those words are defined by other words. And like if you kept looking up words, you could keep looking up words in the dictionary over and over and over again, and it would all just be circular. Eventually everything would be defined in terms of everything else. And so it's like nothing has any actual meaning. In geometry, to avoid this, we have three terms that are not given definitions. We describe them, but we don't give them specific definitions. And those three undefined terms are point, line, and plane. And that's why we started with those the other day, or today in class. And so those are the three terms. We're going to describe what we think of them, but we're not going to give them like real definitions, like hardcore definitions. So what is a point? A point is a location in space, but it has no width, no length. It's just a spot. It's just a location, and you have to think of it as infinitely small. If you put a bunch of points together, you still don't have anything there because points are just locations with nothing actually to them. So that's going to be the way we think of a point. When we think of point, we don't think of it as having any width or anything to it. It's just a spot. The way we'll talk about a point is we'll usually just use a single letter. Like if you had a point, like a point there, and it was labeled P, then all you do is, if you're writing about it, you would just call it point P. And so if you just have a capital letter by itself with nothing else to it, you know that it's a point. Okay. Now, how about a line? What is a line? And we talked about this in our video with the matchstick idea. But in the video or in the activity, I said that it was infinitely long, right? And so a line is an infinite set of points in a straight line, lined up straight. I don't want to say a straight line because then I'm being circular. An infinite set of straight points. And so if you want to describe a line, if you want to say, what about this line or what about that line? There's two different ways that you can write it. One way is you can pick any 2 points on that line and say those 2 points, like A, B, and if I just wrote A and B, they'd be points. But to show that I'm talking about the line that goes through them, then I have to write it with the arrows on top. So that's line AB. You could call it that way. Now, what if it had another point on there? I mean, because it does, right? It has an infinite number of points. Well, then that's the same line. So AC would be the same line, and CB would be the same line. These are all the exact same line because all of them are describing the same set of points because it goes forever and ever and ever. It doesn't matter if you say these 2 points and then forever, or these 2 points forever, if they're all lined up. Yeah. The other thing is sometimes they'll label a line with just like a cursive small case letter, so you could also call it line L. So sometimes they'll do that in the book, and you'll see that sometimes. Okay, how about a plane? So a plane we thought of as this flat surface, right? This flat surface, but it could be diagonal, but it's flat forever and ever and ever. And we kind of talked about it being a face on an object, but then in the notes I kind of said, well, but it goes forever and ever and ever in that direction. So a plane, it's hard to draw a plane because it's infinitely going everywhere, But so often what we do is we draw a little parallelogram. This is the way you'll usually see a plane. And then they want to define that specific plane. Then they'll give a few points on the plane, like A, B, C. And how will we write it? We'll just write it, we'll call it plane ABC. Because through A, B, and C, those 3 points, there's only one plane that would go forever and ever and ever, that would be flat, that would go through all of them. Think about like any 3 points, like you take 3 points that are on the desk here. You know, if I have 3 points on the desk, there's only one plane that goes through those 3 points. It's the desk surface. It's this thing, extended forever and ever and ever. There isn't another way to connect 3 points that aren't in a line forever and ever and ever. Okay? So a plane is a flat, infinite sheet. Okay? Collinear points, sorry, move that around a little bit there. Sorry about that. Collinear points are points on the same line. There's no special notation for this. And coplanar points, you can guess this one, are points on the same plane. So, for example, in this one right here, points A, B, and C are coplanar. You can see they're all on the same plane, but they're not collinear. Whereas on this one up here, these points are collinear. They're all A, C, and B are all on the same line, but are they on the same plane? Well, sure. They you could just do a flat sheet on that line. In fact, you could do a lot of sheets on that line, and all of those would be containing A, C, and B. So the points are definitely coplanar. All right. Whoop, motoring. There's no notation for that. Now, a line segment is a real matchstick. Like when we were talking about matchsticks, a line segment is a matchstick. And what it is it's a part of a line between 2 endpoints. So it's part of a line between and including 2 points that we call the endpoints. So, for example, you could have and goes here and it stops. Notice how I'm not putting arrows at the end of it because it's stopping. It goes from D to E and then it's over. That's called a line segment. Now, how are we going to write this? So, if we just write DE, we won't know if you're talking about points or what. If we wrote DE with a line arrow over it, then that would be the infinite one. That's not what we mean. So we have to write DE with a segment over it on the top of it with no arrows. So that way we're describing just the points between D and E and including those endpoints, that segment and nothing more. All right, endpoints, the 2 ends on a segment. I kind of described what those were there. Array is an interesting thing. Array is kind of like a portion of a line starting from an endpoint in one direction. What do I mean by that? I mean, like if you start at one point, I'm just trying to cycle through the alphabet a little bit, and then you follow a line forever and ever and ever. That's array. So it starts at one endpoint on a line, and then it follows the line in one direction forever and ever. So from an endpoint forever in one direction. Mm-hmm. Now we can't just call it G because that's a point. I'm trying to make the point that how you write things is going to tell people what you're talking about. So you have to write things clearly. So we can't just write G, and then and so we could write a little ray thing on the top of it. And so we could say just G with a ray on top of it. But then there's other rays. Like there could be a ray here and there could be a ray here. There'd be an infinite number of rays that could all go around this thing. And so just having G there wouldn't be enough. But if I had G and another point, like H, and you don't have a double arrow. That's just going to look that way. And you draw it this way. Please notice that because G came first, that's the endpoint. Because you can see that G is on the sort of the point side of it, and H is on the going forever side of it. And so GH would be that, that ray right there. Now, if you were talking about, let me just change colors really quickly. I just want to change colors. If you were talking about like this ray right here, starting from H and then going forever through G, that would be HG with the ray on top of it. For some reason, people always draw the rays pointing right on these. Don't know why. And it always starts with the endpoint. You might say, well, could I draw it with the arrow going left? Nobody really does that. They always draw the arrow going right. So start at the endpoint, forever and ever and ever through this other point, and just make sure you start at the endpoint, and the arrow always goes to the right. Opposite rays would be a situation like this. Let's make it a little bit larger, just so it's a little bigger. Christmas colors. We'll make this P, and this is Q, and this is R. Opposite rays are two rays that start at the same endpoint and point in opposite directions. So PQ and PR are opposite rays. So from one endpoint, opposite directions. It's got to be exactly opposite. And the way you can tell, if you haven't noticed it, is that PQ and PR together make a line. Okay, last one. Whew, we got to get done within 15. Intersections. The intersections between two objects, well, I shouldn't write that again. That's just a waste of time. Intersection is all the points the objects have in common. Sorry, I didn't space that very well. All the points the objects have in common. Let me give you some examples. So like if I had two segments, or two lines, since I drew arrows on them, I might as well make them lines, and they have this point in common, that's called the intersection. That's a pretty easy one, right? I mean, I think people think, when they think intersections, because you think of roads, right? You think of two roads crossing, and they cross at an intersection. But intersections can be different. Like, for example, take in this classroom right here where I am. Like, all right, can I bend it over all the way? Yep. So we've got a plane right here. We've got a plane. Here we go. We've got a plane right here, which is the wall. And then we've got a plane down here, which is the floor. Oops, accidentally paused it there. So we've got the plane of the wall right behind me and the floor. And the question is, what's the intersection of those two planes? So what are all the points that are on this wall and also on the floor? And it would be like all the points that are right along the corner, like all the points on the corner, right in the corner of the room. Those are on the floor, but they're also on the wall. And so the intersection of those two planes is actually a line, because all those points would go forever and ever and ever along the edge. Or take maybe we'll do this one. It would be a little bit easier. So take a look at this plane right here and this plane right here, right next to it. Oop, think I'll make it? Yeah, I'll make it. So we've got these two planes right here. So remember that, though, that the planes don't stop where you see them stop. They go forever and ever and ever. So this would extend forever and ever and ever, up and down, left and right. And this one would extend forever and ever and ever, forward and back and up and down. What are all the points that these two planes have in common? And again, it's a line. It's this point like right here and this point right here, like right on the corner. That's on this plane, and it's also on this plane. And so every single point along this corner is